Test review, sections 1 through 4 from chapter 5. Here we go. So the first thing we're going to do is look at 24 divided by 4 and say, hey, that's 6. Now you can say 6 over 1. That negative is just going to come along for the ride in the numerator. And where do we have more y's? In the top. By how many? 3. You could put this over 1, but that's not necessary. So these are going to be quick. All right, what's the largest number that goes into 64 and 24? Well, I would start with 8. So 8 goes into 64 8 times. 8 goes into 24 3 times. Where are there more A's? In the top. By how many? 6. Where are there more B's? In the bottom. By how many? 4. Same sort of deal, but they're going to get a little bit more complex. So now we got to go 3 to the 4th, which is 3 times 3 times 3 times 3. That's 9 times 9, which is 81. And when you have a power to a power, you multiply. Same thing here. There's an invisible 1 there. So 1 times 4 would give us y to the 4th. And there's nothing else to do, so we're done. You can see these are quick hitters, so let's keep going. That little symbol means multiplication. Remember, when we multiply fractions, we try to cross-reduce, then swoosh. You don't have to do it that way on this one, but I'm gonna. So I have p cubed I almost threw myself for a loop there. So there is nothing to cross-reduce. I saw this as a p and a p, but this is a p and a q. Anyways, there's nothing to cross-reduce, so we have to swoosh, and there's an invisible 1 here, so 1 times 5 is 5. When the bases are the same and you're multiplying, you add these exponents. So it's p to the 7th, and then 3. There's an invisible 1 there, so we add the exponents. 1 and 8 makes 9. Let's go into this one. So negative 5 squared is actually 25. Power to a power, we get p to the 8th. And then we get k squared, because there is an invisible 1 there, and 1 times 2 is 2. All over, negative 2 cubed is negative 2 times negative 2 times negative 2. This is 4, so 4 times negative 2 is negative 8. And then there's a 1 there, so 1 times 3 is 3, so p cubed. And then k to the 6th. And now we look at 25 and 8. Good habit to keep the negative upstairs. Doesn't have to be, but that's how most answers will look. Where are there more p's? In the top. By how many? 5. Where are there more k's? In the bottom by 4. All right. What should I do, the top or the bottom first? The bottom, because of good old PEMDAS. I got that exponent down there, which is going to change all of this. So 4 squared is 16. 3 times 2 is 6. There's an invisible 1 there. 1 times 2 is 2. I'm going to bring this along, just slide it on over. I'm going to keep things organized on this one, so I'm going to flip the M, Mama, and the N, Nancy stuff. And there is an invisible 1 there. So if I reduce this, 4/16 reduces to 1/4. Anything divided by itself is just 1. Where are there more N, Nancy's? In the bottom by 1. So there would be my answer. Keep it going. More multiplication. On this one, I can cross-reduce. I'm going to say, hey, there's 2 of them down here. There's 3 of them up there. Where are there more? There's 1 more on the top. The 3 goes into 3 once. The 3 goes into 9 3 times. Where are there more x's? There's 1 more x in the top. So we just cross-reduced. Now we're going to swoosh, which is just xy all over 3. Same sort of deal here. And notice these parentheses are there to try to confuse you a little bit. If this 3 was up here, then we'd have to cube everything. But that 3 just goes along with the b, and that's it. So this is really 4 times 3, which is 12b cubed over 6 times 3 over b to the 6th. My recommendation all trimester long so far has been when you multiply fractions, you cross-reduce. So I'm going to go ahead and do that. You could go 6 into the 12, or you could go diagonally. Let's go 6 into the 12. So that'd be a 1, that'd be a 2. Where are there more b's? There's 3 more in the bottom. So now I swoosh straight across. I get 6 over b cubed. That's not the only way to do it, but that's a good way to do it. All right, we're all the way to the back side here. There's a lot of problems on this review, so let's keep on moving. This says express without negative or zero exponents. Well, what did we learn? We learned that if there's raised to a negative exponent, you got to put them where they ain't. So these two are going to flip places. So it's going to be 5y squared all over x cubed. Done. This one's got a little bit more going on here. Now the way I would do it is I would concentrate on the numerator first, and I'd go, aha, power to a power, I multiply, power to a power, I multiply, and now I'm just going to rewrite this stuff on the bottom, c to the negative 4, d to the negative 2. All right. Well, what I'm going to do is I'm going to recognize that these are all negative exponents, so everything, this and this and this and this, they all need to go where they ain't. So they all need to flip. So I'm going to write this as c to the 4th d squared. I'm bringing the bottom stuff up, taking the top stuff down, and then after you've honored the negative exponent, the command goes away. Now I can get into my basics. Where are there more c's? Well, in the bottom. By how many? 2. What's 2 cubed? 8. What happens to that? Nothing. So there you go. Again, there's more than just that way to do it, but that one I think is just pretty straightforward. So what happens on the next one where we have a negative exponent and this is a fraction? Well, that's just a different way of saying flip it. So that's what that turns into. And then the same thing goes with this one. So this one would turn into b over a cubed, and that's to the first power. And I'm going to go ahead and honor this, so that'd be b to the 4th. There's an invisible 1 here, so 1 times 2 is 2. And this is just b all over a cubed. I try to cross reduce, I can't, so I swoosh. What do I do when I multiply and I have common bases? I add the exponents. And there it is. On to the next one. Let's remember the rule. Anything to the 0 power is just 1. So that kind of just disappears. But I'll bring it along. And then I go power to a power, so I get u to the negative 3, v to the 6th. And again, there's different ways to do this, but the way I'm going to do it is I'm going to go power to a power, so I get u to the negative 1, and then 2 negatives actually make a positive, and that's my first step. Now, one thing I'm going to do is forget about this 1 because it doesn't really matter. I'm going to swoosh first because I can see I can't cross reduce. So when the bases are the same, you're multiplying, you add the exponents. Even those are negative, don't panic. So I get negative 4. And this is 6 plus 2, which is 8. Now look at the instructions. It says without negative or 0 exponents. See, we have a negative exponent still there, so we got to drop that underneath, put it where it ain't. So we get 1 over u to the 4th, v to the 8th. And there it is. Okay, number 13. And we're moving quite quickly. The one thing that I recommended during this whole section was factor, 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 hactor, 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 which means we take a look at the top and factor out as much as you can to get started. So I can take out a 4x to the 4th, leaving me with x minus 2 all over 12x cubed. Now if you want to take a look at this, 4 and 12 reduces to 1/3. Where are there more x's? 1 in the top, and then that would turn into just x. I'm ignoring that 1 times x minus 2 all over 3. Now you could distribute this, but it's really not going anywhere, so we can just leave our answer right there. So again, factor, factor, hactor, hactor. What can we take out of here? An a. What's left? a squared minus 9. Now, is this completely factored? No, it is not. So we're going to keep going. This is a. This is a difference of two squares. So remember our rules. One of them is a plus, one of them is a minus. Take the square root of that, put it first. Put the square root of that second. And now this is completely factored into that. This is simply a God-of-1 trinomial. And so that means we can go right to our parentheses. I know this is going to be a and a. What are two factors of positive 9 that add up to negative 6? That'd be negative 3 and negative 3. So these are both negatives. Now there's the factoring. Now the fun part, factor. And that's it. What's left? A times a plus 3 all over a minus 3. If you want to keep this in parentheses, it's probably a good idea. And you can't go any further because there's nothing identical. All right, the big temptation on this one is just to cross out the 2y squareds. Remember, you just can't do that. I showed a lot of those examples in class. Remember the rule, factor, 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 factor. This is an auto one, so we're going to multiply those, and we're going to get negative 8. Two factors of negative 8 that add up to 7, negative 1, and 8. Now I'm going to rewrite this as 2y squared minus 1y plus 8y minus 4. Insert your parentheses. Now factor it, or take out as much as you can from this one. So it'd be y, 2y minus 1. Here I'm going to take out a 4. And I'd be left with 2y minus 1. Notice we get a little excited when we see that these match, because that's going to be 2y minus 1 times y plus 4. And we're done factoring that one. Now we got to do the same thing with this one. So 2 times 4 is 8. Two factors of 8 that add up to 9. Well, that's 8 and 1. So we can rewrite this one as 2y squared plus 8y plus 1y plus 4. Insert parentheses, and now factor as much as you can out of that. That'd be 2y, y plus 4. You can't take anything out of here. There's nothing in common, but you have to take something. So I'm going to take a 1 out. And now I'm ready to take this, take these out, because that's y plus 4. Then whatever's left is what goes in the second one, 2y plus 1. You can see that these cancel. These are not exactly the same, and they're not exact opposites. So we just write our answer like that. Now, if you want to put those in parentheses, you can. It means the same thing. Number 16, can I take out these y squareds? No. Can I take out these 16s? No, because of the subtraction and addition. So I got to factor this. And because it's a God-of-1 trinomial, I say, hey, what two factors of positive 16 add up to negative 8? That'd be y minus 4 and y minus 4. Notice this is a difference of two squares. So one's going to be plus, one's going to be minus. You take the square root of the first term to figure out what goes first. Square root of the second term determines what goes second. And now I notice that these are the same, and that I can't go any further, so this would be my answer. Okay, so here's number 17. There's just more going on. Notice this is a fraction divided by a fraction. So if I just peeled off that much, this is the same thing as 2c squared d over b times, now I got to flip this one, 2b squared all over d squared. Now I'm not going to worry about this quite yet. I'm going to clean this up if I can. So I see that there's 1d up here and 2d's down here, so I'm left with 1 down. 1b there, 2b's there, so one of those up. And now I'm going to swoosh, put things in alphabetical order, so bc squared all over d. Now that's times bd all over 8c. Here's your classic cross-reduce swoosh. 2 goes into 2 once, 2 goes into 8 4 times. I got 1c down here, 2 of them up here, so I'm left with 1 up there. These d's are canceling, and then I swoosh. So what do I got in the top? Well, I got a B